Have you heard the word?
That ship has sailed away.
Cooper, when did you hear the word dilate? Your eyes, right? Has anybody had their eyes dilated?
Yeah.
What's it mean? What happens? What, Mason? Yeah, so like the black part of your eye, when they dilate it, they enlarge it, and you actually don't really have any color then around your eye. And it opens up your lens, which also then lets in a ton more light, and you find yourself very, very light sensitive. Like when people have their eyes dilated, a lot of times they just want to sit in a dark room because when your pupil opens up more, it's letting more light in. Okay, so when dilations happen, it's changing the size of something. The pupil of your eye is staying a circular shape, but it's getting larger, it's getting smaller, and that's what our last transformation today is that we are making an object larger or smaller. We're changing the size of an image. If it was a square, it's going to stay a square. If it was a triangle, it's going to stay a triangle, but it's going to change size. They always use the letter K for scale factor. I don't know why, but that's just the chosen. So an enlargement, or when the image is bigger than the original, happens if K is greater than 1. If your scale factor is greater than 1, it is going to make your object larger. A reduction, or if your image after you dilate it is smaller than the original, if K is greater than 0 but less than 1. If you want to write that in words, greater than 0, less than 1. 97% of the time you are not going to have a negative scale factor. The negative doesn't change what it does to the image, it changes its location. That's why you don't usually see it. And it will be the same as the original figure if K equals 1. Your object will not change size if you have K equals 1. So the pre-image and the image are the same shape, but not necessarily the same size. So we cannot use the word congruent. When you're talking about dilations, you cannot use the word congruent. Do you guys multiply? You can do today's dilations. Dilating means you multiply by that scale factor. So part A says, a figure has the vertices W, X, Y, and Z. Right here, I'll highlight those. Find the coordinates of the figure after a dilation with a scale factor of 2. Before we do anything, because the scale factor is 2, what do you know about, after you dilate this, what do you know about the object? It'll be bigger. It's an enlargement because K is greater than 1 or your scale factor is greater than 1. All you have to do is multiply your X and your Y by your scale factor. So all you have to do is multiply every single coordinate by your scale factor of 2. So W prime would be -4, 8. X prime would be 2, 8. Y prime would be 6, -2. Good. And Z prime would be -6, -2. Exactly. This is one of those times, have you ever heard that saying, KISS, keep it simple, stupid?
Yeah.
Okay, this is one of those times, don't overthink it. KISS, K-I-S-S, keep it simple, stupid. Okay, now I know your guys' graph sucks. So are you good if we don't graph this?
Yeah.
Because I know your graph sucks. Okay, so normally you'd graph these points and then you'd graph after the dilation. So I want you guys to find me the points after a scale factor of 3. Don't worry about the graph because I know the graph is tough. It did not copy well.
You did the last one.
Bless you. All right. F prime would be located at -3, 3. G prime would be located at 3, 3. H prime would be located at 6, -3. And I prime would be -3, -3. Okay? The other part of what we're going to do is, like, see, bless you again. Mrs. Bowen's homeroom is creating a web page for the school's website. They need to reduce a scanned photograph so it's 720 pixels by 320 pixels. If the scanned photograph is 1080 pixels by 480 pixels, what is the scale factor? So this time we need to figure out, what do I need to multiply by to get my new size? There's a key word in there. Somebody tell me a key word that's going to make sure I can double check my answer is right. Reduce. If I'm making a reduction, what do you know about my scale factor? It's got to be less than 1 or greater than 0. To do this, you always put the image divided by the pre-image. And people sometimes screw that up, so I'm going to remind you. This is the new one divided by the old, or maybe I should say original instead of old. You got to take the new size divided by the original to figure out what they multiplied by. What are one of the new dimensions, bless you? 720. And what original dimension does 720 match up with? How do you know that, Caden? Oh my gosh, I keep doing that. I saw your brother last night, that's why. Jacob, which does 720 match up with? Why? But I could change the order of them. So why do you know that 720 matches up with 1080? What? Very good. Between the two dimensions, 720 and 320, 720 is larger. Between 1080 and 480, 1080 is larger. So we're going to put this on here. Now tell me what you're going to tell, before we even divide this, what do you know about this? How do you know? It's going to be smaller, so it's got to be less than 1. But what do you know about your answer? More than 0, less than 1. It's going to be a decimal, but Ms. Hoff really wants us to leave it as a fraction. So we need to reduce this. Okay, the easiest thing we know, they both end in 0, so it's like dividing a 10 out, right? So we could take 72 and 108. What are some numbers that go into 72? 2 would. Okay, so if I divided 2 out, 72 divided by 2 is... You guys should be able to do this in your head. 36. 108 divided by 2, 54. Okay, can you reduce those further?
I don't know. Yes.
What do you want to divide out?
Isn't it 9?
6?
Can't 9 go in
We
there?
can divide a 6 out. 36 divided by 6. 36 divided by 6 is 6. 54 divided by 6 is 9. Can you go further?
3.
Divide by 3. Which gives me 2/3. Which stands true? It's greater than 0 but less than 1. So let me get this right. If I ever see a scale factor that's a fraction, I'm guaranteed it's a reduction. True or false?
Can you repeat that again?
If I have a scale factor that's a fraction, it's guaranteed to be a reduction. True or false?
I feel like it's like a trick question.
It is a trick question.
False.
It's false.
Yeah.
Because what if my scale factor was 3/2? That's a fraction. Why is that not a reduction?
Because
It's over 1. AKA, it's an improper fraction, right? If you have an improper fraction, it's still going to be an enlargement. All right, one more, and then I'm going to turn you loose. Find the coordinates of the vertices of the figure after a dilation with a given scale factor. What's different about this one? Yes, it does.
Oh my god.
It's a fraction. Okay? It's a fraction. Now, when I multiply with the fraction, I take the number and I put it over 1. So let's just say I'm going to make this up. 52 over 1. And I multiply by 1/4, which would mean I multiply across. So I end up with 52 over 4. So instead of multiplying by 1/4, what could I do? Really, it's like dividing by 4. Okay, so when you multiply by 1/4, it's like dividing by 4. I don't want you to use decimals. Okay, so really we need to take and we need to divide each of these by 4. So J prime, 0 what? -1. K prime, 0, 2. L prime, 1, 1. Stop talking and it wouldn't be fast. You guys talk the entire time. If I had you listen to this recording, there's never a moment of quiet. And so people that are struggling probably get super frustrated in here. And even if they're not struggling, some of your classmates are beyond frustrated because there's never quiet. Dilations are all about scale factor. Now, these graphs did a lot better, did they not? Okay, so they graphed the original. They want you to dilate it, get the new points, and then plot them on that graph still, okay? So you do have to graph on 1 and 2. This one started with a decimal. Could you give me a decimal answer? If you use 3.75, that's fine. Same thing on 4, same thing on 5. 6. 8 is a drawing. Don't overthink 8. 8 problems. Can you handle it? All right, rock and roll. Bless you.